Hello friends, today we are going to start with CBSE class 4 playing with numbers. So let's begin our chapter. So this chapter is mostly dedicated with factorials, multiples, numbers, their properties and many more things. So in this exercise 5.1 we need to find first 5 multiples of these numbers. So let's see the answers. So in order to find first 5 multiples of these numbers, we are going to multiply them from the digits 1 to 5. So first 5 multiples of 3 are 3 into 1 equals 3, 3 into 2 equals 6, 3 into 3 equals 9, 3 into 4 equals 12, 3 into 5 equals 15. Okay, so done with the first example. Let's go for the second one. So we got here 4. So first 5 multiples of 4 are 4 into 1 equals 4, 4 into 2 equals 8, 4 into 3 equals 12, 4 into 4 equals 16, 4 into 5 equals 20. Next we got 7 with us. So 7 into 1 equals 7. 7 into 2 equals 14, 7 into 3 equals 21, 7 into 4 equals 28, 7 into 5 equals 35. So here we got first 5 multiples of 7. Let's see our next number. We got 10 with us. So first 5 multiples of 10 are 10 into 1 equals 10, 10 into 2 equals 20, 10 into 3 equals 30, 10 into 4 equals 40, 10 into 5 equals 50. Let's see our next example. We got here 12. So for 12, we will find the first 5 multiples. They are as follows. 12 into 1 equals 12, 12 into 2 equals 24, 12 into 3 equals 36, 12 into 4 equals 48, 12 into 5 equals 60. So we got our first 5 multiples of 12. Now we got 50. So first 5 multiples of 50 are 50 into 1 equals 50, 50 into 2 equals 100, 50 into 3 equals 150, 50 into 4 equals 200, 50 into 5 equals 250. So here we are done with the first question. Now let's see the next question. So we have to do here do as directed. So we have to find out multiples of 13 out of all of these numbers. So here we got 26, 92, 45, 27 and 39. So we know that 26 and 39 are multiples of 13. So let's circle them. Alright, here we go. Next we have to find multiples of 20 out of these numbers. So here we got 100 and 80 as multiples of 20. So let's circle them out. In next we have to find the multiples of 15. So multiples of 15 are 45 and 150. So let's circle them. Alright. Now next we have to circle multiples of 25. So out of these all 75 and 225 are multiples of 25. So let's circle them out. Yeah, there we go. And this question is also done. Okay, let's move ahead. We have to write the missing number over here. So we have to write here multiples of 2. So they have already given us two numbers 16 and 24. So we have to write the numbers which will come before 16, in between 16 and 24, and some numbers after the 24. So here we will start with the 14, 16, 18, 20, 22, 24, 26, 28. Okay. Now we have to find out multiples of 25. Again they have given us 100 and 175. So we will start here with 25, then 50, 75, 100, 125, 150, 175 and 200. So this is how we got multiples of 25. Next we got multiples of 9. So here they have given us 36, 63 and 90. So we will begin with 27, 36, 45, 54, 63, 72, 81 and 90. Next we have to find multiples of 11. So we have to start with 33, then 44, 55, 66, 77, 88, 99, 110. Okay, so here we are done with the missing numbers. Alright, so this is how we are done with exercise 5.1. Now we will start with the exercise 5.2. So here exercise 5.2 is mainly related with the multiples and common multiples. So what are the common multiples? There are many numbers which are part of tables of a lot many numbers. Let's say 8. 8 comes in the table of 2 as well as 4. So 8 is a common multiple for 2 and 4. So here we have to write multiples of 2 and 3 and their common multiples. So multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, right? I have taken first 12 multiples of each number. You can take as many as you want. Multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. So their common multiples are, as you can see here, 6, then we got 12 and we got 18 and 24. So let's write them down. 6, 12, 18, 24. Next we got 6 and 8 together. So multiples of 6 are 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, 72, right? First 12 numbers we are taking. Multiples of 8 are 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88 and 96. So their common multiples are 24, 48, 72. Alright. Now we will move towards next digit. So that is 5 and 10. So as you know, 10 is multiple of 5. All the numbers which are multiples of 10 are obviously multiples of 5. So multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Multiples of 10 are 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So their common multiples are 10, 20, 30, 40, 50, 60 and you can write as many as you want. Next pair is 4 and 12. 4 multiples are 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. Multiples of 12 are 12, 24, 36, 48, 60, 72, 84, 96, 108, 120, 132, 144. So here the common multiples are 12, 24, 36, 48, right? Now next we have to write multiples of 10 and 15. So multiples of 10 are 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Multiples of 15 are 15, 30, 45, 60, 75, 90, 105, 120, 135, 150, 165 and 180. Let's write their common multiples. It's 30, 60, 90 and 120. Okay, so here we are done with completing this table. Let's move towards our second problem. So we have to write multiples of the following numbers in their respective circles with their common multiples in the center. So let's go ahead. So here we have to write multiples of 3. So we have written 3, 6, 9, 15, 18, 21, 27, 30, 33. So we have to find out multiples of 4 as well. So multiples of 4 are 4, 8, 16, 20, 28, 32, 40, 44, 48. So their common multiples are 12, 24, 36. Okay, let's move ahead with our second problem. So here we need to write down the multiples of 12. So multiples of 12 are 12, 36, 60, 84, 96, 108, 120, 132, 144. Now we have to write multiples of 8. So multiples of 8 are 8, 16, 32, 40, 56, 64, 80, 88, 96. Their common multiples are 24, 48 and 72. Now we have to write multiples of 4. So again multiples of 4 are 4, 8, 16, 20, 28, 32, 40, 44, 48. Multiples of 6 are 6, 18, 30, 36, 42, 54, 60, 66, 72. Their common multiples are 12, 24 and 48. Now in the next problem we have to write multiples of 2. So there are 2, 4, 6, 8, 12, 14, 16, 18, 20, 22, 24. Now we have to write multiples of 5. So it's 5, 15, 25, 30, 35, 40, 45, 50, 55, 60. Their common multiples are 10, 20. Okay, so let's move ahead. Now properties of factors. Let's see that the smallest factor of every number is 1. So for example, factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. It means 1 can divide every number and we already know this fact. Okay, so 1 is a factor of every number. For example, factors of 7 are 1 and 7. It means that 7 is divisible by 1 and 7 only. Next, the highest factor of every number is the number itself. For example, factors of 10 are 1, 2, 5 and 10. Every number except 1 has at least 2 factors. For example, factors of 5 are 1 and 5 and factors of 9 are 1, 3 and 9. Finally, every number is a factor of 0. So for example, let's take example like 0 into 6 equals 6, 0 into 120 equals 0. Based upon these properties, we have to solve exercise 5.3. So we have to find factors of the following numbers and we have to complete the table. We have to find factors of 20. So how to do that? Let's find out. So 20 divided by 1 equals 20. 20 divided by 2 equals 10. Friends, if a number divide another number completely, that is without any remainder, then only that small number is called as the factor of that bigger number. Okay, here 20 can be completely divided by 1, 20 can be completely divided by 2. That's why we consider them as 20's factors. 20 divided by 4 equals 5. Yes, you're right. We haven't considered here 3 because whenever you try to divide 20 by 3, there is a remainder of 18. This is a very mandatory thing that we need to understand which number can divide the other one. Yeah, we are going to see it in the upcoming video. Okay, 20 divided by 5 equals 4. 20 divided by 10 equals 2. Now here also we have skipped 6, 7, 8 and 9 because we know they cannot divide 20 completely. 20 divided by 20 equals 1. Hence the factors of 20 are 1, 2, 4, 5, 10 and 20. Okay, let's find out factors of 18 now. So 18 divided by 1 equals 18. 18 divided by 2 equals 9. 18 divided by 3 equals 6. 18 divided by 6 equals 3. 18 divided by 9 equals 2. 18 divided by 18 equals 1. So the factors of 18 are 1, 2, 3, 6, 9 and 18. Okay. Let's move ahead. We have to find factors of 15. That's completely easy. So factors of 15 are 15 divided by 1 equals 15. 15 divided by 3 equals 5. Yes, 15 cannot be divided by 2 completely. There will be remainder. 15 divided by 5 equals 3. 15 divided by 15 equals 1. Hence, the factors of 15 are 1, 3, 5 and 15. Now, our next thing is 42. So, factors of 42 are 42 divided by 1 equals 42. 42 divided by 2 equals 21. 42 divided by 3 equals 14. 42 divided by 6 equals 7. 42 divided by 7 equals 6. 42 divided by 14 equals 3. 42 divided by 21 equals 2. 42 divided by 42 equals 1. Hence, the factors of 42 are 1, 2, 3, 6, 7, 14, 21 and 42 itself. Let's see what we got. Yeah, this is the last one. We have to find the factors of 35. So factors of 35 are 35 divided by 1 equals 35. 35 divided by 5 equals 7. 35 divided by 7 equals 5. 35 divided by 35 equals 1. So the factors of 35 are 1, 5, 7 and 35. Okay, fine. Now we have to write yes or no. So factors of 12 are 1, 2, 3, 4, 6, 8, 10 and 12. So out of this like 1, 2, 3, 4, 6 are factors of 12. 12 is factor of 12 but 8 and 10 are not factors of 12. Hence we have to write no over here. Now factors of 16 are 1, 2, 4, 6, 1, 2, 4, 8 and 16 which is yes. 1 is factor of 1 only. Yeah, we have seen this as property. So this is also correct. So yes. Factors of 30 are 1, 2, 3, 5, 6, 10, 15, 30. What do you say? Absolutely right. So we will write yes over here. Every number except 1 has at least 2 factors. It's also one of the most important property which is yes. So we will start with now with common factor. So common factor, there are many numbers which can divide more than one number completely, that is without leaving any remainder. These numbers are called common factors. just like common multiples, we have common factors as well. So let's see, our next exercise is depending upon common factor. So we have to find the common factors of the following: 15 and 9. So factors of 15 are 1, 3, 5, 15. Factors of 9 are 1, 3, 9. So their common factors are 1 and 3. Let's see the next one, 20 and 24. So the factors of 20 are 1, 2, 4, 5, 10 and 20. Factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. So their common factors of 20 and 24 are 1, 3, 4. Okay, let's move ahead. We have to find common factors of 12 and 14. So for that we will find out factors of 12. They are 1, 2, 3, 4, 6, 12. Factors of 14 are 1, 2, 7, 14. So their common factors are 1, 2. Let's find out the factors of 30 and 45 and their common factors. So factors of 30 are 1, 2, 3, 5, 6, 10, 15 and 30. Factors of 45 are 1, 3, 5, 9, 15, 45. So the common factors of 30 and 45 are 1, 3, 5 and 15. So we have to find common factors of 21 and 49 now. So factors of 21 are 1, 3, 7, 21. Factors of 49 are 1, 7, 49. So their common factors are 1, 7. Now we have to find common factors of 45 and 60. So factors of 45 are 1, 3, 5, 9, 15, 45. Factors of 60 are 1, 2, 3, 5, 6, 10, 15, 20, 30, 60. Hence, the common factors of 45 and 60 are 1, 3, 5, 15. So this is how we have finished the finding common factors of these numbers. In the next problem, we have to again write the common factors in the circles. So factors of 48 are 8, 12, 16, 24, 48. Factors of 36 are 9, 12, 18, 36. Their common factors are 1, 2, 3, 4, 6 and 12. Now we have to find factors of 20. So they are 4, 5, 10, 20. Factors of 18 are 3, 6, 9, 18. Their common factors are 1 and 2. Next is we have to find factors of 35. So it's 1, 7, 35. Factors of 50 are 2, 10, 25, 50. Their common factors are 1 and 5. We have to find factors of 5. Actually, the factors of 5 are same like factors of 30. So we have written directly it in the common area. So factors of 30 are 2, 3, 6, 10, 15, 30. Their common factors are 1 and 5. So this is how we have completed finding the factors. Our next topic is prime and composite numbers. So the number that has only two factors, 1 and the number itself, are called prime numbers. For example, 2, 3, 5, 7, etc. So actually 2 is treated as the smallest even prime number. The numbers that have more than two factors are called composite numbers. For example, 4, 6, 8, 9. Now 1 is neither a prime number nor a composite number. Based upon this, we have to solve exercise 5.5. So we have to sort out the following numbers as prime or composite numbers. So these are the numbers given to us. So here we have to find out whether that number is divisible by only the number itself and 1, or there are more factors to that number. So let's see here. 13. What do you say? 13 has only two factors, 1 and 13 itself. So we'll write it as prime number. Then we have 54. 54 is a composite number. 37 is again a prime number. 96 is a composite number. 36 is a composite number. 29, yeah, it's a prime number. 42 is a composite number. 89 is a prime number. 45 composite number. 61 is a prime number. 10 is a composite number. 41, 79, both numbers are prime numbers. 69 is a composite number. 90 is a composite number. 5 is the prime number. 72, 84, both are composite numbers. 97 is a prime number. 27, which is again divisible by 3, is a composite number. 53 is a prime number. It is divisible by 1 and the number itself. 91 is a composite number. 92 is a composite number. 79 is a prime number. 7 is another prime number. 21 is composite number. 17 is a prime number. And 73 is a prime number. Okay. So it's simply categorized as the number which are not part of tables of any other numbers apart from their own. So they are considered as prime numbers. Okay, now we will start with the next. We have to answer the following questions. So write the first three prime numbers. So first three prime numbers are 2, 3 and 5. We have to write the numbers, write the prime numbers which are less than 10. So the prime numbers which are less than 10 are 2, 3, 5, 7. Okay. Now we have to write prime numbers which are factors of 15. So we know the factors of 15 are 1, 3, 5 and 15. So the prime numbers which are factors of 15 are 3 and 5. We have to write the prime numbers which are greater than 20 but less than 30. So in between 20 and 30 these numbers are sandwiched. So the numbers which are prime numbers which are greater than 20 but less than 30 are 23 and 29. Next question. We have to find out the smallest composite number. Any guesses? Yeah, the smallest composite number is 4. How come? 2 to the 4. So it is the smallest composite number. All the composite numbers are even. Tell me whether it's true or false. Of course it's false. Out of 17, 19, 11 and 15, which number is a composite number? So we know that 17, 19 and 11 have only two factors, 1 and the number itself. 15 is the only digit which has more than two factors. So here 15 is a composite number. Okay, so done with this question. So here we go. Now we have a new topic, even and odd numbers. So we are dealing with the numbers, so we need to categorize them as even and odd numbers. So numbers ending with 0, 2, 4, 6, 8 are known as even numbers. Isn't it simple? We just need to look at their ones place and you will be able to answer whether that number is even or odd. Numbers ending with 1, 3, 5, 7, 9 are known as odd numbers. So these are the examples: 13, 25, 37, 79. These are all odd numbers. In addition, the addition of two even numbers is always even number. Let's add 10 and 8 together, you will get 18. If you add 50 and 70, what will you get? 120. It's again even number. Addition of two odd numbers is always even number. Isn't it fantastic? If you add like 5 and 7, you will again get 12. If you add 9 and 3, again you will get 12. Okay, the addition of an odd number and an even number is always odd number. Let's add 2 and 3 together, you will get 5. If you add 11 and 2 together, you will get 13, isn't it? So you will get always odd number. So depending upon this, we are going to start with exercise 5.6. Okay, so here we have to answer the following questions. When we buy a dozen eggs, we buy an odd number of eggs. True or false? We have to tell it. So it's false because a dozen means 12 and 12 is an even number. So whenever you buy a dozen eggs, we buy even number of eggs. Do we buy an odd number or even number of shoes? So what do we buy? We buy an even number of shoes, that is 2. 2 shoes, like a pair of shoes, that is 2. Odd numbers must end with 1, 3, 5, 7, 9. True or false? Yes, this is true because we just saw this property. So answer is true. Okay, next question. When we add 7 and 18, so 7 is odd, 18 is even. Do we get an even number? True or false? It is false because we will get 25 and 25 is an odd number. Next, do cars usually have an even or odd number of tires? So cars usually have, yeah, tell me. Yes, 4 tires. So and 4 is an even number. So cars usually have even number of tires. Next question. Difference between 391 and 173 is an odd number. True or false? So if you look at these both numbers, they are odd. Let's find out their difference. So the difference between 391 and 173 is 218. So it is an even number. Alright, so we are done with our first question. Here we have to find the solution to these problems. So first is, Jen has recycled 5034 plastic bottles. Her mother recycled 6789 bottles. How many bottles did they recycle together? Is the number odd or even? So if you look at these numbers, okay, first number is even, the next one is odd. Okay, and now in order to find out the total, we need to add them. So let's add. So we'll write it like this. Number of plastic bottles recycled by Jen equals 5034. Number of plastic bottles recycled by Jen's mother equals 6789. If we add them together, we will get 11,823. So this is the total number of plastic bottles recycled, and the number 11,823 is an odd number. Okay, now we got the next problem as Ronnie the bee. Oh, we got a bee over here, and the bee's name is Ronnie. Visited 2654 flowers on Saturday. It visited 4576 flowers on Sunday. Look at these numbers. The both numbers are even numbers. Do you think Ronnie visited odd or even number of flowers? So addition of two even numbers will give you exactly even number answer. How can you say? But to be confirmed, we will add both of these numbers. So this is how we write it. Number of flowers visited on Saturday equals 2654. Number of flowers visited on Sunday equals 4576. So here we will add them together. We will get 7230. So total number of flowers visited equals 2654 plus 4576. So this number is even, and we already knew that. Alright, let's see the next example. Sam baked 1697 cookies on Wednesday. He baked 1359 cookies on Thursday. Now look at these numbers. 1697 it's odd. 1359 again odd. Okay, he baked this number of cookies on Wednesday and Thursday. How many cookies did he bake in all? What we have to do again, addition of these two numbers. Did he bake an odd or even number of cookies? So if we look at both of these numbers, they are odd, and addition of two odd numbers will give you an even number. But we will confirm it. So how to write it? Number of cookies baked on Wednesday equals 1697. Number of cookies baked on Thursday equals 1359. Hence the total is 3056. So total number of cookies baked equals 3056, and it's an even number. Now next one. In a school there are 2648 boys and 4222 girls. What is the total number of students in the school? Is the number odd or even? Again look at these numbers. Both of these numbers are even. So let's add them. So number of boys equals to 2648. Number of girls equals to 4222. Their addition will give us 6870, which is again even number. So total number of students, which is 6870, is even number. So here we have completed our exercise. Now we will move towards the divisibility rules. Students, please remember these divisibility rules. They are very important and you can use them throughout your life for considering, like, you can just guess, simply guess which number will be divisible by what number. So we have divisibility rule for number 2. So all even numbers are divisible by 2. That is, the number ending with 0, 2, 4, 6, 8 are divisible by 2. Thus, we look at the ones digit of a number to find whether the number is divisible by 2 or not. Let's see the example. 65376. It is divisible by 2 because its ones digit is 6 and 6 is an even number. Okay, so all the even numbers are divisible by 2. Now next rule is for number 3. So divisibility rule for number 3. A number is divisible by 3 if the sum of the digits of that number is divisible by 3. Thus, if the sum of all the digits is a multiple of 3, then the number is divisible by 3. Let's see the example. 3570 is divisible by 3 as the sum of 3 plus 5 plus 7 plus 0 equals 15, and 15 is multiple of 3. Okay, so these are the two important rules. Next we will see divisibility rule for number 4. So divisibility rule for number 4 says that a number is divisible by 4 if the number formed by the last two digits, tens and ones of that number is divisible by 4. Okay, so for example 1428 is divisible by 4 as the number formed by the last two digits is 28, which is divisible by 4. So obviously any numbers ones and tens places we'll have to see. Next is divisibility rule for number 5. A number is divisible by 5 if it ends with either 0 or 5. That is, if the number has 0 or 5 in the ones place. Example is 2650 is divisible by 5 as number ends with 0. Divisibility rule for number 9. So the divisibility rule for number 9 and 3 are same, but there is a catch. Any number which is divisible by 3 doesn't mean that 9 will also can divide that number. Okay, for example 12 is divisible by 3 but it is not divisible by 9, so don't get confused in between both of these. A number is divisible by 9 if the sum of all its digits is divisible by 9. So let's example 9180 is divisible by 9 as the sum of 9 plus 1 plus 8 plus 0 equals 18, and 18 is multiple of 9. Okay, can you tell me, is this number divisible by 3? Yes, of course. This number is divisible by 3 because 18 is again divisible by 3. Divisibility rule for number 10. Oh, it's very simple. A number is divisible by 10 if it ends with 0. That is, a number which has 0 in ones place is divisible by 10. So 3440 is divisible by 10 as number ends with 0. Okay. So depending upon this divisibility rule, we have our next exercise. So exercise 5.7. So we have to guess the answer and correct the color the correct circle. 84 is divisible by 3. Yes or no? So what is the addition of 84? 8 and 4 together will give you 12. And 12 is divisible by 3. Yes. Okay, next is 92 is divisible by 5. Yes or no? Of course no. For a number to be divisible by 5, it should end with 0 or 5. And 92 doesn't end with 0 or 5. So it's no. 53 is divisible by 3. Yes or no? First thing, the addition of 5 and 3 are 8. So it's not divisible by 3. And actually 53 is a prime number. So a big no. 153 is divisible by 9. Yes or no? So addition of 1 plus 5 plus 3. What is it? It's 6 plus 3. It's 9. And yes, 9 is divisible by 9. So yes, over here. Okay. Now we will move towards our next question. Here we have to state whether it's true or false. If the number is an even number, it can be divided by 2. True or false? Very simple, right? It's true. Next is, if the ones digit of number is 5 or 0, it cannot be divided by 5. No, that's false. If ones digit is 5 or 0, it is definitely divided by 5. So this statement is false. If the sum of all the digits of the number is divisible by 3, it can be divided by 9. So as I told you earlier also, it's false. If a number is divisible by 10, it can be divided by 5. Yes, of course, because we know if a number is divisible by 10 means it will end with 0, and property of 5 digit is also says that if a number ends with 5 or 0, it will be divisible by 5. So this is true. So here we have solved all of this. Now we will start with exercise 5.8. So we have to find we have to complete the factor trees. So here we are given with 30. One of the factor of 30 is 3. So if we divide 30 by 3, we will get 10. So here we got another factor as 10. Now we are given with 2, which is one of the factor of 10. So if we divide 10 by 2, we will get 5. So this is how we complete the factor tree. Next we got 63. One of the factor of 63 is 9. So obviously the other factor will be 7, as 9 sevens are 63. Now we have to find factors of 9, which are 3 threes are 9. So here we got 3 and 3. Okay, let's move towards our next tree. So we got here 56. So one of the factor of 56 is 7. So if we divide 56 by 7, we will get 8. For 8 we got here 4. The other factor of 8 will be 2. And for 4 the factors are 2 and 2. Okay, let's complete the next factor tree. We got 27 over here. If we divide 27 by 3, we will get 9. Again, factors of 9 are 3 and 3. Alright, so this is how we have completed the factor tree. Now we have to move towards next problem, that is we have to create all the possible factor trees of 64. So here first we will start dividing 64 by 2. So we will get here 32 and 2. Next now we cannot further divide 2 into multiple factors. So we will move towards next. So 32 will be divided into 2 and 16. Again 16 will be divided as 8 and 2. 8 will be divided as 4 and 2. 4 will be divided as 2 and 2. So we got all the possible factors of 64. Right? Let's move towards our next question. So we have to write the prime factors using the division method. So this is also called as the vertical method. So let's start it. We have to find prime factors of 20. So we'll write it like this. First we will start with 2. So if we divide 20 by 2, we will get 10. Again 10 will be divided by 2. So we will get 5. So we cannot divide 5 by 2. So 3 no, 4 no. So we will directly divide 5 by 5. So we will get 1. We have to follow this process till we get 1. So the prime factors of 20 are 2 to 5. So we will write them as 2 into 2 into 5. Next we have to find prime factors of 16. So we will write it like this. 16. First we will divide 16 by 2. We will get 8. We will again divide it by 2. We will get 4. Divided by 2. We will get 2. It cannot be further divided. So we will get finally 1. So here we got prime factors of 16 as 2 cross 2 cross 2 and cross 2. Okay, next we have to find prime factors of 32. So here we go, 32. First we will divide by 2. We will get 16. Divided by 2, we will get 8. Divided by 2, we will get 4. Divided by 2, we will get 2. And finally 1. So prime factors of 32 are 2 into 2 into 2 into 2 into 2. Next we have to find prime factors of 48. So prime factors of 48 are, first we will start dividing it by 2. We will get 24. Then if we divide further by 2, we will get 12. Again divided by 2, we will get 6. 6 divided by 2, we will get 3. Then 3 will be divided by 3, and finally we will get 1. So the prime factors of 48 are 2 into 2 into 2 into 2 into 3. Alright. Next we have to find prime factors of 81. So 81 divided by 3. Yes, we know that 81 is not even number, so we will directly start with 3. So here we will get 27. 27 divided by 3, we will get 9. 9 divided by 3, we will get 3. Again 3 divided by 3, we will get 1. So prime factors of 81 are 3 into 3 into 3 into 3. Now we have to find prime factors of 54. So here we go. 54 by 2 will get 27. 27 divided by 3 will get 9. 9 divided by 3 will get 3. 3 divided by 3 will get 1. So the prime factors of 54 are 2 into 3 into 3 into 3. Okay. So here we come to the end slide, and I would like your comments. I would like to get your comments, and please like, share and subscribe to our channel. Till next video, bye bye.